A tangle of what looks like cosmic cotton candy in deep space is making us rethink our origins. There's a lot hidden in these new observations.
Today is May 24th, 2025. Let's dig in. The Hubble Space Telescope has just sent back an image of the Large Magellanic Cloud. That's the Milky Way's largest satellite galaxy, about 160,000 light-years away. Why is this new image important?
This image isn't just for show. Hubble's Wide-Field Camera 3 captured a colorful region of nebula in the Large Magellanic Cloud. What we're seeing are delicate clouds of gas and dust, almost like candy floss, set against a backdrop of stars. But beyond the aesthetics, these structures reveal how stars and planets form, and how galaxies change over time.
So it's not just about the colors. The camera uses ultraviolet, visible, and infrared wavelengths, right? That means astronomers can combine several kinds of data. Why is that such a big deal for understanding the universe's history?
It's because we're not just getting a snapshot. Alongside this image, astronomers also found oxygen and heavier elements in a galaxy 13.4 billion light-years away. That might sound a bit abstract, but it's quite significant. In the early universe, there was only hydrogen and helium. Finding heavier elements means that stars had already formed, lived, and exploded. So even a few 100 million years after the Big Bang, there had been several generations of stars.
Let me check I understand. If the universe began with just hydrogen and helium, where do these heavier elements, or metals as astronomers call them, actually come from?
They're formed in the cores of stars and released during supernova explosions. So when we detect those elements in ancient galaxies, it's evidence that several generations of stars have already existed and died. That helps scientists improve their models of how galaxies, including our Milky Way, formed and grew over time.
The Large Magellanic Cloud also contains the Tarantula Nebula, which I've read is the most active star-forming region nearby. What can these nebulae teach us about the life cycle of stars?
By studying regions like the Tarantula Nebula, we see how gas and dust come together under gravity to create new stars. When we analyze the light from these areas, we learn more about the process of star and planet formation, possibly even worlds that could support life.
And Hubble's Wide-Field Camera 3 uses different filters to isolate specific wavelengths, right? What does that let astronomers observe that wasn't possible before?
Yes, exactly. WFC3 lets astronomers identify different gases, temperatures, even track how material moves. The cotton candy look isn't just for effect. It's actually data showing where stars are forming and how matter is mixing.
Looking ahead, the James Webb Space Telescope is set to outdo Hubble in infrared. How is that going to change what we can find out?
Webb will peer even further back in time, with much greater sensitivity in the infrared. That means it can detect the chemical signatures of the earliest stars and planets. We'll be able to see details from the universe's first few 100 million years, answers Hubble can't provide.
These advances also show how international teamwork is key. NASA and ESA have worked together on Hubble. What does this kind of cooperation mean for the future of space science?
It's vital. Hubble itself is a partnership, and these discoveries show what's possible when agencies pool their resources and knowledge. As projects like Webb and the European Extremely Large Telescope come online, international collaboration will only be more critical for big scientific progress.
If we step back for a moment, why do these images and findings matter to people who aren't astronomers?
They remind us that our beginnings are shared and that discovery is a collective effort. Seeing these distant wonders brings us together, and every new piece of knowledge reshapes our sense of place in the universe.
So, today we looked at Hubble's latest image from the Large Magellanic Cloud, the finding of heavy elements in the farthest known galaxy, and why discoveries like these matter for science and for all of us.
Thank you for joining us as we explored how cosmic cotton candy is changing what we know about the universe's first stars, the technology behind the discoveries, and the importance of working together.
Thanks for listening. This episode was brought to you by mynews.studio, Try it now for free.